Hi, everybody. In this video, we're going to get started with PostgreSQL. We're going to learn how to install it on Linux. We'll kind of learn the basics of SQL. What is it? What does PostgreSQL have in common with MySQL? What's kind of the theory behind all of these? Learn how to create databases and tables and how to insert some data. So let's get started. Here I am in Linux. Let me just kind of clear my screen so we can kind of have a look at it. And the first thing I want to do is kind of update what Ubuntu or what Linux knows about what programs can be installed. So these systems have sort of like a catalog of what programs are available, and as part of this catalog it says what versions there are. So I can install version 10 point whatever of Postgres. So we need to kind of update this catalog in order to get kind of the latest edition of all these things, or so it knows about all these things. And that command is sudo. So sudo runs the whatever we type in after it as the super user, so root privileges, and apt-get update. So that's going to update that catalog. Okay, and now that we've updated it, we can actually install the program. What we want to install is PostgreSQL. I guess you'll see how to spell it in a second. And that command is simply sudo apt-get install -y for yes. It just means don't ask me questions about whether to install it or not, just install it. And the command I want to install is the program I want to install is PostgreSQL. So that'll go ahead and install that program, PostgreSQL. After it installs the program, it'll automatically start the program. So a program that auto starts and runs in the background, meaning we don't see any kind of displays or windows on our screen when it's running, that's called a service. So a service is a program that auto starts even when we shut the computer down and turn it on again. This program will start up immediately again without us telling it to start up. So it's rare that we'd actually have to restart the server. So let's, in order to see what services we have running on a machine, we can do service status all. And it's a long list of things that auto start and run in the background. So here's PostgreSQL, but if we installed MySQL, it would be the same thing. It's something that runs in the background. It's a service. If we installed a web server like Apache or Nginx, that would also be a service. So a service is simply a program that auto starts and runs in the background. Okay, so back to Postgres. So one of the first things, and let me just kind of clear the screen. One of the first things we'll need to do is one of the first things that it's good to do is to create a password for that root user in Postgres. The root user in Postgres is unsurprisingly called Postgres. And so let's go ahead and create a password for Postgres. And that command is, again, sudo. We want to run this command. And this time we want to run the command as user, which is why the U is there, as the user Postgres. And the command I want to run is PSQL. Now, PSQL is the client that'll connect to the database server. So what we have running in the background is a database server. We'll learn more about this, or our idea of what this is will kind of solidify as we progress. But PSQL is a client that connects to this database server. So that's what this does. We're going to run this client. And now once we execute that, we're inside Postgres and we can interact with that Postgres server. The only thing I want to do at this point is create a password for the user Postgres. And that command is \password and then whatever user I want to set the password for. So in this case, it's going to be Postgres. But if I want to set the password for the user music, I would just do like that. So I'm typing in a password here. And now let me quit Postgres. So it's \q. What that quits is the client. That Postgres server is running all the time. So it's a service. The program's running all the time. I can connect to it using this program called PSQL. So let me connect to it. So it's PSQL. This time it's a big U, and that's what user I want to log in as. In this case, I want to log in as Postgres. Now with PSQL, I can log into Postgres servers that are anywhere. We might have a Postgres server running on, let's say we have a server running in Dallas or in who knows where, somewhere in Virginia. We can connect to it by issuing, what machine we want to connect to, and that's what host we're connecting to. In this case, we're just running on our laptops or desktop, so it's just going to be localhost. So PSQL -u for user, Postgres, -h, what we want to connect to. It's the Postgres server running on my local machine. And now I'm in. So now we're into Postgres. So before moving on to actual what are the commands in Postgres, let me just back up a step and talk a little bit about the structure of SQL databases in general. So far what we've been doing is we've created a server, so that's running, so it's a piece of software that runs, and on this server it can store one or more databases. So we might have database 1, these are just my bad names, they can be called whatever we want, another one, and so on. These databases contain kind of logically related information. I'll get into more details in a second, but just think of this is some logically bit of information, and this one is logically bit of information. Within a database, that information is stored in a number of tables. So we might have 2 tables here and just maybe 1 table here, or however many we want. So that's sort of the structure. So suppose we work in an IT department of a small town. Let's imagine in New Mexico or somewhere. And this small town has one server we're running, a Postgres server, and it might have a database just that has to do with stuff in the library. So we might have a table that has just all the information about what books we have in the library, right? So it would be like that might have some information about the title, the author, the publication date, some ID number, and so on. We might have a table having to do with our patrons. Maybe it's a first name, last name. Maybe we have an ID number. Maybe we let patrons kind of reserve books online, so they might have some sort of password, and so on. And finally, we might have, or maybe not finally, but in addition, we might have some sort of table that says, well, what books are checked out by what patrons? So I don't know what to call it. Checked out, let's call it. All right, so we have, like, let's say the book ID. So that book is checked out by maybe the patron ID, and so on. And date, maybe there'd be something about the due date or whatever. So all this information is stored in multiple tables, and those tables are under the hierarchy of one database. They're all logically related. There's stuff related to a library. Our small town might have other information related to maybe property. We tax property. So one table might be property info. That might have the street address. Then there's those addresses like plot 4 of this section or something. So legal address, I don't know what to call it. The size, lot size, home value, whatever information about homes. We might have something about owners. So first name, the same stuff as before, first name. Legal address, social security number maybe, and then we have maybe just something that combines them, property owners. So we might say, well, an owner can have more than one property, so I might do that. So we have some sort of idea of owners, some connection with owners and property. So the thing to see here is that all this information is sort of logically separated from this, right? So we have all the information of the library in the library database, all the information about properties in the property database, and all these, and we can have many more databases, they all can be under one database server. So the idea is that we have a database server. A database server contains one or more databases, and within a database, we have these things called tables, And tables are pretty much like what you think a table is. So if you look at a spreadsheet information or make a little table in Microsoft Word or wherever, it's that same sort of format where we have rows of information and we have columns associated with particular attributes of that thing. So we might have a book table. Each row is a book, and the columns are like title, author, pub date, etc. So that's kind of the basic idea behind what we're trying to encode, the information that's going to be in a database. So let's go back to Postgres here and see how we do that. We create a database by just saying create database, and we can create a database. Let's go with library, and it ends with a semicolon. So that creates a database called library, and we can see all the databases by going \L. And there we see that indeed we have a database called library. We have other databases too, and those are ones that are automatically created when we install Postgres, but here's the one we did with library. Case is irrelevant in Postgres, so even though when you look at a book about SQL servers, you'll see all the commands are in capital letters and the things we're creating are in lowercase, it doesn't matter. I could go CRETE, whoops, if I could spell it. Now let's create one called property. And if I look at that listing, I'll see that there's property right there. It doesn't care about the case in this case. There's other database servers that do. You can configure MySQL that does, but for the most part, in order to be most applicable, your code to work on any database server, it's best to kind of think that it's case insensitive. So I've showed you how to create databases and how to look at them with the \L command, list the databases. We can get rid of a database by just saying drop database. And let's say I want to get rid of the property one. And you see that property one is absent. One common error related to creating databases and almost every other command in SQL is to forget to put that semicolon. And sometimes it's difficult to see. You would think it would work, and it's not an obvious error. So let me just kind of show you that. So let me create a database. It's called foo and hit return. So here, the only indication that we know it didn't work is that we didn't see the code repeated. So here when I created one, it comes back and says create database. Here it didn't do that. So I can simply add my semicolon in and it'll go ahead and create it. So keep that in mind. So now I've created some databases. I can actually use a database or kind of move to that database and create some tables within it by this command \C for I want to change databases. This here on the left of this equals pound is what database we're currently connected to. So right now we're within the Postgres database. If I want to change to the library database, it'll say I'm now connected to library, and that appears there. So let's go ahead and create a table. So as the syntax is fairly similar to the database one, in this case it's create table, and we can give it a name, like let's say we want to create one called books. And then we give a list of the name of the column. So the syntax is sort of like column. Let me switch to just so I can type without worrying about screwing up. So the syntax is something like this: create table, table name. And then we have, so column one name and data type. I'll give examples of this in a second. Column two name. And so on. So let me show you. And then there's a semicolon at the end. So let's see how that works. So let's say I want to create a table called books, and it has a title, which is of type text. I'll talk about that in a second. And let's just say it has an author of type text, just to keep life easy here. So I'm going to close that up in the semicolon, which is very important, and it creates a table. Let me talk a little bit about what these different types are. So I have text, which is, as you can imagine, strings of data, text data. And the possibilities here, let me just open that up. So the data types we can have are integer. I think that makes sense, right? Just regular numbers. We can have numeric. So those can have decimal points, decimal numbers. We can have this type text. And those, well, let me get another one here. We can have date, like 2020, 10, 07. So that's a date. And then those pretty much account for the majority of what you'll need. There's some others. They're more historical. You can have char, and you can, which stands for character, and you can say how many characters you want. So 2. So this means that there always is exactly 2 characters. And an example of when you might want that is if you're doing state abbreviations like Arizona or Massachusetts or New Mexico, or maybe in that case you'd want char 2. In looking at kind of the computational costs of this, there's no advantage of char 2 over text. So I always thought that if you knew exactly how many there were and there was only 2, you could probably optimize things. But it doesn't seem like that's the case, at least in current research, as far as I know. So that may not help, and it's really not needed. But for historic reasons, you might see that. At least it makes sense. It helps you understand what kind of data goes in there. We have varchar, which is a variable characters, a variable number of characters, and this is going to be whatever the max amount is. So this would say at most there can be 10, but you can also have just 2. So if we had, and we just wanted to store the word an in that char 10, it would be an 3, 4, 5, 6, 7, 8, 9, 10. The varchar, if we had 10 and stored an in it, it would just be an. So that's varchar. So these are the basics. We'll learn a bit more later, but to create ones, we would use integer, numeric, text, and date. That'll get you pretty far. There are these others as well. There's many others, by the way. We'll examine some of them later, but certainly you can Google what the other options are. So here I've created a table. I can see what the tables are by \d when I'm in the, so this is asking the question, please tell me what the tables are, and I'm in the database library, and it says I have one called books. I can see, well, what's the structure of books? What do those columns look like? So it's \b again, and I can say books. And it'll say, well, there's a title and an author. I can drop it. Maybe. And now if I look what's in there, nothing. So that's good. Let me show you, once we create larger tables or tables with more columns, it gets to be kind of a hassle to type them directly in here. And we can create the structure of our tables in a file and then just read in that file. So let me show you how to do that. So let me switch to my editor here. And I'm using Sublime. I really like Sublime, but let me create a new thing here. And let's say I want to create a database. And let's go, I'll drop that database library. So I'm creating the database library. Remember, I need to change into the database in order to create tables within it. Okay, and let's say I have create table books. Okay, so let's see what I have in it. Let's say I have an ID, which is of type integer. So just some ID number of what the book is. I have the author. Let's keep things simple and assume there's only one author for each book, and that's of type text. I have the title. That's of type text. I have, I'll just call it pub date. And let's call that good. And let me just save that. And let's call it library. So I'm calling it library.sql. All right. Let's go in this. Let me get out of this to get to the right directory. So there's my library SQL file. Let me just cat it to see if it looks good. Okay, that's what we just typed in. Okay, so there's two ways of reading in a file. One is, so here I am on the Linux command line. I can just go PSQL -u for user, Postgres, -h for what host I want, localhost, and then I can go -file, the file name, and I can say library.sql. I can see that's going to create a problem because I didn't get rid of the library database, so let me do that. Oh. That command again was drop database. Okay. All right, now I can do it. So that command is PSQL. It says user Postgres host. And now I can specify the file. In that case, it's library SQL. So that's the one method of reading in information from a file is just to do it on this Linux command line. Okay, and let's see if it worked. So let me go into, so when it executes that way, you can see it doesn't, you don't end up in Postgres. It just executes the command in Postgres and then leaves Postgres and you're back to the Unix command line. So let me go into Postgres. Okay, and now remember I have to change in the library. And now I can look at what tables there are. They're books. Remember, I dropped it before, so that's good. Let me look at the structure of books. So that looks good. Okay, let me drop that. Let me get out of this. Well, here's one thing. You can't drop a database that you're currently in. Remember, I'm in library. That's it's on the left here. That's showing that. And if I try to drop it now, oops, I missed the semicolon. You can't drop the currently open database. So what you need to do is change to some other database. Now I can drop that database. So that's one way of reading in files into Postgres, and that is from the Unix command line. You can simply add that -f for file and read that in. The other way is once you're in Postgres, you can just insert information from a file with this \i command. \i insert, and I want library.sql. So there I am. I can look at books, my books thing, and there I have that information. So we've now seen how to create databases, how to delete databases. We've seen how to create tables and delete tables. And we've looked at these / commands of how to kind of navigate throughout the information on a server, how to change to a different database, how to look at all the databases, how to look what's the format of a table, and so on. The format of a table, again, is this \d. To change to a database is that, and so on. So the only thing we haven't done is actually insert any information into a table. The only thing we haven't done, that's kind of the easy rudimentary stuff we're doing. So let's see how to do that. So that simply is insert into, and now it's the name of the table we want to insert into. So we books, and now we list what the columns are that we're inserting. We want to insert ID, we're going to insert author, title, and pub date. So those are describe the columns. So, and now the values is what do I want to insert there. So this is my first book. The author is Anne Mulkern. And she wrote the book, Gusty Cooper and the Pie. And what's left is the pub date, and that was published 2018, 09, 10. So that's the syntax. Insert into the name of the table we're inserting into, books. These are the columns, so I'm giving it the ID number. So the first thing I'm giving you is the ID number, so that's 1. The next thing I'm giving you is author, that's here. Next thing, title, and finally the pub date. This tells me that it did insert. And I can show that this. We'll learn about select in more detail later, but we can just say select everything from books, and it should show me the entries. So right now I have 1 entry, Anne Mulkern and Gusty Cooper and the Raspberry Pi, and that's the pub date. I could insert another. Again, case is not important because that I can go books. And these are, let's say I'm going to do things a little differently. I'm going to give it the title, the ID number. Next, I'm going to do the author and the pub date. Okay, so the title in this case is Gusty Cooper. The ID number is 2. The author is Anne Mulkern. And the pub date is 2019. Sorry. And let's do that select statement again and see what we have. So now we have 2. So you can see I can change the order of how I'm putting the information in. In this case, I did ID, author, title, pub date. But in this case, I did the title first, ID, author, pub date. And the alignment here is that after this value, Gusty Cooper and his electric bike, that as I zip over is the title. The next thing I'm giving it is the ID and so on. So I've successfully added 2 things to the database. One thing that's not recommended, but it is allowed, is, I shouldn't be doing this. Let me just do it from scratch. So insert into books. I can leave out the column names and just say values. Let me do it in caps so you see where the division is. And then that means whatever I type here has to be in the exact order that I used for creating the database. Namely, in this case, it's the ID number, author, title, and pub date. So the ID number is 3, let's say. The author is, let's just stick with Anne Mulkern. The title is Gusty Cooper. And the pub date is 2020. That's future pub date, apparently. All right, so now I can do the select. Whoop. So there. This is not considered, this syntax that I just showed up here is considered bad form because it relies on something hidden, namely you knowing the order of how things appear. So even though this is allowed, it's not the recommended way of doing it. All right, let me show you one more thing here of how to insert multiple entries or multiple rows into a table. So here I'm back at the editor, and just to make life easy, let me just call it libraries with a Z at the end just for, and we've seen the insert statement, which looks like insert into books, ID, author, title, pub date. And remember, I could have put these in any order I want. And I could have here just one row insert statement. And if I wanted to put in another row, I would just have another insert statement. But there is an alternative. And let me just kind of paste this in. So I could do this where I have multiple entries here. This represents one row of the data. And then I have a comma. And then I can put in another row. And I could keep going as many as I want, and then I end the last one with just the semicolon. So that's sort of the, just make sure I'm not screwing anything up. Let me save that, and here I'm back at library, and let's just insert that into let's just insert that into our database and see if that works. And apparently it did. So if I do select splat from books, I get those entries. So those are the basics. I would like you to try. So just kind of try adding a table, like maybe a patrons table. What information would a library patron, what kind of would be the columns, and insert some examples there. Or do something totally different, like a pets database or a dog breed database, or you name it, whatever idea you have, just to get a little bit of practice in creating these things, creating a database, creating tables within a database, inserting some basic information, and doing that very simple select statement. And next time we'll look at enhancements to this. Thanks. Bye.